Good day and welcome to the first video in this series, Introduction to Statistical Analysis and Machine Learning with R. I'll be your tutor for this series and I am Abbas Olaya. Basically what we want to do in this series is check through different aspects of things in statistical analysis with R. So we check what R is, why will we use R, installing R on your system, introduction to R Studio, data structure manipulation and sampling, data import, exploring data analysis, exploratory data analysis, loop, that's for loop and while loop, if else statement, data exportation, that is when you are done with the data, how you export it. So what is R? R is an extensive object-oriented programming language like Python, but R is majorly used by statisticians. So that's that on that. But for example, as we are running this series, we are running a series simultaneously with it, which is on Introduction to Statistical Analysis and Machine Learning with Python. So in case you are interested in learning Python too as you are learning R, you can follow the two together. It's actually good to have the two tools in your box, in that most of the time when I want to do data analysis for organizations and what I want to use majorly is probably I want to plot a lot and the likes like that, I will run to R, and when I want to do maybe some sophisticated machine learning, I run to Python. Not that R cannot do machine learning, but R is a bit memory intensive, so I run to Python for machine learning problems. So that's that on that. Then an integrated suite for software facilities for data manipulation, simulation, calculation, and sophisticated graphical display. Exactly what I just said. Then started by Robert Gentleman and Ross Iaka, hence R, like their two names started with R, so just name the programming language R. As a free, independent, open source implementation of S-Program. S-Program, I have not really used S-Program before, but it was the S-Program that instigated these two guys to actually start this project R. And R has been here for a long time and I don't think it's going anywhere for the years to come. So it handles and analyzes data very effectively, and it contains a suite of operators for calculation on array and matrices. Currently maintained by our core development team, an independent group of hardworking volunteers. So you can join this team actually, but you need to finish this course first. Okay, R is free. So why you should use R? R is free. It contains built-in functions and you can install more. Then it is flexible in that you can write your own code. Then it has the interactive console for debugging and testing. So why learn R? These are different reasons: open source, cross-platform compatibility, advanced statistical language, outstanding graphics, flexible and fun, extremely comprehensive, support extension, vast community, relates to other language. Yeah. So if you want to install R, you can go to this website for the Windows installation or this for the Mac installation. So then in this course we'll be using R Studio majorly. Reason being that the R programming language is more like you're using a command line. So R Studio is more interactive in that you have different interface that makes your work easier. And okay, this is the interface. Now we have the script display. This is actually what R would have showed you. Then we have workspace and history of commands. So this one will give you your history, that is the variables you've defined, the data you've imported, and the likes like that. Then this is your console here. Your console shows you what you've run and the response to what you ran. Then here is where you see your graphics, your plots, and also you can also pick packages from this place. So this is the package management console too. So that's that. Then the next thing is, okay, data structure and manipulation. This is where we actually have to get back to R and start coding. So this is what R actually looks like. So here we are going to start R basics. So basically what we are going to be doing is show you the different things how you can manipulate arrays, data, and import data with R. So let's get started. So to comment in R, we use hash, or I call it Naira sign, but in case you are not in Nigeria, you don't know what I mean by Naira sign, you use the hash, that's the hashtag symbol. Then, mind you, R is case sensitive. So whenever you are defining your variables or writing your parameters, be mindful of the case of your alphabet. There are large repository and documentation. So in case you run into any problem, just write question mark and whatever the problem is. For example, let me just run question mark. Let's say exp. So if I run this now, it will give me an explanation of what I ran here is here. So these are the various places we can use exponential and the likes like that. So this is the logarithm and the likes. So whenever you run into any problem, you can use the question mark, or you can use the double question mark, which gives you it's taking a while to run. So it gives you everything you can lay your hands on with the exponential symbol. So that's on that. So try to run codes as I teach. Yeah. Then what I use in running my code, in case you don't know, is after writing the code on a particular line, I use Control Enter. So Control plus Enter will run the code for you. Then if you have any question, please put your question in the comment section of this video. Thank you, and let's get started. So basically 3 plus 7 is 10. So that's what we are saying here. So that's why I said you write your code here, then you run, whenever you run them, they show here. This is actually what we would have had if you just open R on its own. So let's go on. The exponential 3 will give us, oh sorry, I use Shift Enter. I forgot I'm not more in Jupyter Notebook. So exponential 3 will give us 20.08. Then 2 times 5, 10 divided by 4. 2 times 5 plus 10 divided by 4. Mind you, it's better to use your bracket. In case, if you are in Nigeria, if you went to school in Nigeria, you would have had something when we were in primary or secondary school. We call it board mass. Board mass. So this is basically what all programming languages actually follow. So you start, it checks what is in bracket first, then off, then divide, multiplication, addition, subtraction. So here now, what is the first check is what? Division. Then if you check multiplication, then check addition. There's no subtraction. So that's why we got the answer we got. For example, if I had put probably a bracket here, and run, would have gotten a different answer entirely. So be mindful of your, so log 5 will give us 1.609. So then variable assignment, we use equal to assign variables, or we can use this, that's less than minus. You can use it to assign variables too. I actually use less than minus most of the time rather than the equal to sign. But equal to sign seems easy for most people. But it makes me feel geeky when I use less than minus. So it feels like I'm actually coding, not just writing inside my notebook. So that's that on that. So you can see in our environment, we have A defined as a variable already. So if I change A to A plus 4, A will automatically change here. So that's that on that. Then B equals exponential 5. It defines B too. So we can also use dots and underscore. So in our variable, in naming our variable, we can use dots, we can use underscore. Unlike some other programming language, you can use the dot in your variable name. So we can use it here. So exponential 2. So you can see that C equals 2 times 3. D equals 10 divided by 4. Exponential 2 will be printed out for us. D will be printed out for us. Then list of all the variables we have in our working directory. You can see A, B, C, D, exponential minus 2, and some 1. So to print all of them out for you here. Whereas you actually have them here too. So that's that on that. So we can remove any one of them. For example, I want to remove some 1 now. If I remove, if I remove some 1, it will automatically remove it from here. And if I list all the variables in our environment, we don't have some 1 any longer. So vector 1 will give us 1 to 10. Vector 2, 1 to minus 10. Vector 3 equals sequence 0, 5 by 0.5. That is, give us numbers between 0 and 5. Then let the common difference be 0.5. So that's basically what that sequence is doing there. So that's that on that. Then if we want to check the length of a vector, so we can check length vector 1. Then vector 4 equals sequence 0, 5 with length equals 15. So the sequence will have equal differences, but the length will be 15. That's basically what that code is telling us. Then by 0.5, I was explaining the other time, that's the common difference will be 0.5. So we can say 1 to 3, then let the length be 5, meaning they will have equal common difference. So this concatenation, that's just putting variables in a vector without any particular pattern. So you write your own pattern yourself. So x equals the first concatenation, y equals second concatenation. Then we can have characters in our vector instead of the normal numbers. We can have characters also. Then position. So this vt equals first, uva equals second, ru equals third. So if we put this, I will explain more on this later as we go on in this course. You can actually call them like the way we did dictionary in Python programming. In case you're interested in learning Python programming, I actually did a series. It's actually still ongoing. That's 0 to 1 in Python programming. You can always check out the videos. In fact, you check the first 15 videos, I'll show you are already an intermediate in Python programming already. So that's that about that. Then the next thing is repeating and replicating values. So rep 1 equals rep 1, 5. Rep 2, that's repeat 1 in 5 times, 5 places. So if I check for rep 1 here, if I have rep 1 here, so that's rep 1. You can see we repeated 1 in 5 places. We are repeating A in 4 places for rep 2. We are repeating this vector in 5 places each. Each of them will be repeated 5 times. So if you check, everything will be repeated 5 times. So rep 4, we repeat this in this number of, that's like making a matrix. So that's that on that. Then arithmetics with vector. So x plus 1 will give us all the variables, all the values in x plus 1. So the first one plus 1, which is 1 plus 1. Second one plus 1, that's 2 plus 1, like that until we get to the last one, which is 5, which will now give us 6. So 2 times x, to multiply everything in the vector by 2. Then 2 raised to power x, x raised to power 2 actually. Each of the values in x raised to power 2. Then 2 raised to power x, that's 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, like that. Then x plus y, x times y. So each of the variable values in the vector will multiply by each other. Then we have the dot product. Dot product is basically like multiplying everything together, which will give us a single value. So when we do dot product of x and y, it gives us 28. You can check that yourself if you've done vector and matrix manipulation while you are in the college or something. But in case you don't understand what this is doing, I'll be running a series simultaneously with this too, which is the mathematics behind statistical analysis and machine learning. So in case you are interested in the math behind all these things, I'll be explaining most of the math we'll be doing, because the math are a bit ginormous, so I won't be able to explain everything, but I will explain as many as possible. For example, this dot product will be explained in the next tutorial in that particular series. So that's that. So v plus v, v1 plus vector 1. Mind you, the length needs to be the same. If not, might run into some problems. Then sum of x, that is sum of the variables in vector x, sort y, that is sort them numerically, the lowest first, the highest at the end. Then round, as round up all the values in vector 4, round them up to 2 significant figures. So that's what this is doing for us. So